time, and then we're gonna learn some new ideas today, and then you actually have a lot of like practice time and then time after to work on Doubts Math or retake review stuff if you choose to do so. And if I do forget, somebody remind me after we're done with our practice to hand back your Unit 6 test. I do know I often forget to hand back tests. So we have log of 1 over 100. If I just see log, what base does that mean? 10. Great. So if you need to write it in that little 10 or remind yourself, go ahead and do that. I saw a lot of people rewriting it as x, and that's a great idea to help you write it as an exponent. How does that look as an exponent? Oh yeah, you're like kind of already thinking about the answer, right? 10 to the x gives us 1 over 100. And then Yada, what were you saying? What exponent would that be? Right, 10 to the negative 2 would be equal to 1 over 100. And if I have log base pi here, whoa, don't freak out because you see a pi, because it's of 1, and I know anytime I'm taking a log of any base of 1, what is that always going to equal? 0. Great job. And if you weren't quite sure why, think about it. You're like, pi to what power would give me 1? Oh, I know that must be 0. Let's look at our next question. We have ln of the cube root of e to the 7. And if I see ln, if that's scary to me, how can I rewrite that? It's log base e, yes. So I have log base e. And if you want to rewrite that as an exponent, it's e to what power gives you the cube root of e to the 7. And I know if my bases are the same, my left side will equal my right side, but my exponents are the same. And I think about, I want to know what's this exponent equal. So on my right side over here, I could rewrite that as e to what power?
7 over 3.
Yeah, which means that all of this should be equal to 7 over 3. And lastly, we have log base 32 of 8. And if you're thinking about your swoosh, you have 32 to what power can give you 8? Now I'm going to think about 32 and 8. If I'm thinking about 8, I'm like, okay, 8 times 8, 64. I don't really know. That's not match up with 32. What could we do if those numbers aren't matching up? What do you think, Laura? Amazing. The base they both have is 2. 2 to what power is 32? Yes. And then if it's raised to x, that just becomes 5x. And then 2 to the third power is 8. Same idea. My bases are the same, so therefore I can just set my exponents equal, which means this is going to be equal to 3 over 5. So where we're going today is properties, and before we get there, what questions do you guys have with evaluating? With your properties, if you ever come across a scenario that you're going to have to evaluate, you want to evaluate. So kind of take these ideas, don't forget them, and we will keep building off of them. What other questions do you guys have here? All right, you guys are in for a treat. Properties are fun. They're kind of like puzzles. So with puzzles, right, sometimes you might be doing a puzzle and you have the same common end goal. Sometimes there might be a different way to go around it, so that's okay. So just kind of keep that in mind. There's not always like a systematic like steps to follow, like there can be sometimes in math. So we have lots of rules with our logarithms. And let's start to kind of see how they are connected. So here's my addition rule. I have log base A of m plus log base A of n, meaning my bases are the same. If I have two things added together, I can bring them together through multiplication. So two things I forgot to mention are always happening that we're going to be working on with logs. You're going to either have multiple log expressions that you're condensing all into a single expression, or you have a single expression and you're breaking it apart. And why we have to do this is these are all skills to help us build up towards being able to solve exponential and log equations. So if I see addition, I combine it together through multiplication. But I also go in reverse, meaning if I see multiplication, I break it up with addition. Now with my next rule, I have log base A of m minus log base A of n. So with subtraction, I bring them together through division, because that's equal to log base A of m over n. Now I go the other direction. If I see division, I break it up with subtraction. Before we kind of go through the other rules, let's talk about these two. Addition pairs with multiplication. Subtraction pairs with division. What other time in math have those operations gone together?
Exponents.
Yes, exponents. Why does that make sense? Logs are the what of exponents?
Inverse.
The inverse. So they are connected together. So if you are ever forgetting your rules, don't freak out, don't fret. Stick to your exponent rules. Multiplication, addition, division, subtraction. Those pair together. What's your other rule with exponents? If you have a power raised to a power, what do you do with those two? You multiply them. So that's going to be kind of like your power rule here, meaning if I have log base A of m raised to some power, I multiply that power by my log. So you're basically, anytime you have an exponent, bring it out to be the coefficient. If I have a coefficient, I put it back to be the exponent. Kind of the same idea with your inverse property, with your power rule, same ideas. This just kind of builds off the idea of log base A of A. If I am taking the log and my base and what I'm taking the log of are the same value, what will that always equal? What was that? 1. Because A to what power gives you back A? 1. So kind of think about here, this just becomes 1, and your exponent goes out in front. So that would be K. So basically, another way to think about that is if we have log base 2 of 8, we know 2 to what power gets us 8? 3. You could also rewrite that as log base 2 of 2 to the 3rd power, and that 3 goes out in front, and I multiply that log base 2 of 2. That I know is always 1, which is 3 times 1. So, different ways to think about it. Like I said, different routes to your thoughts, and that's okay with this stuff. Now I have log base A of 1. We talked about that last time, and again in the warm-up, we know that's always equal to 0. So I see a couple of you guys still writing stuff down. So I'll give you a couple more seconds, and then we'll get started with our examples. So, 2 things we're always doing. Bringing things together or breaking them apart. All right, let's keep going. So I want you guys to take a moment and jot this question down, and then we'll talk about what the directions mean and how we can think about doing it. All right, so our directions. Condense into a single logarithm. So, does everybody see? Single. 1 log expression. In this case here, we have ln. So our answer should just have 1 ln. And notice we are starting off with multiple. So I have ln of 50 minus ln of 5 plus ln of 2. So think about those rules we just talked about. What are you guys noticing with our question? What's something we got going on? Yes, all of them have the same base of log of e because we have ln. Good thing to know. We can't combine things unless they have the same base. So like that's good check 1. What else do you guys see? I see subtraction and I see addition. So let's talk about subtraction first. If I want to bring things together with subtraction, we divide. So what do you think this would be equal to? Ln of what? How did you get ln of 10? Yeah, so if you need that extra step here, ln of 50 over ln of 5, which just gives us ln of 10. And I'm going to write that extra step since we're just learning our rules right now. So if I see subtraction, I bring it through with division. Now I have plus ln of 2. I still have that going on. What do we think about that? Plus ln of 2. Yes, that means multiply. So that doesn't mean times ln of 2 here. What that means is I times 2 inside the parentheses. So that is now going to become ln of 10 times 2 all in the parentheses, which will just give us ln of 20. So you guys are just learning right now, so we're going to take things slow, and you're going to have a couple steps with your problems, and that's okay. Once you get really comfortable, you get to be like a pro, like, you know, and you're going to just be able to look at things and see, okay, I have ln, it's 50 over 5 times 2, and then you can just be like, boom, there it'll be. It's 20 from there. So kind of think about you'll keep doing that, and you'll see a lot more with like your exponents and with your variables too. So, what questions do you guys have so far? Keep your operations in mind, and if you sometimes with math we're kind of like programmed to just like do this and this and that. Take a second before you start each column, just like observe like what you have. So let's take a second, jot this question down, and like observe. What do you have going on? So what observations did you guys make? Notice our question condensed into a single log. And what observations did you guys make with what we were given?
We have power rule.
Ooh, Evan, tell us, how do we know we have the power rule?
What's the coefficient?
Yes, we have coefficients. So thinking about, like I said, there aren't really steps to this, but there are steps to this. In the sense of order of operations, right? Parentheses, exponents, then you multiply, divide. Here, same idea. Exponents before you multiply or divide when you bring things back together. Because I can't say I'm multiplying this until I put those exponents back with those variables. So this coefficient becomes your exponent. So this is log of x cubed plus log of y squared. Now, what do we see?
Log x cubed y squared.
Yes. And you know what everybody, I feel like, is struggling with the most? Remember when you have two things in math next to each other, you often don't see the symbol, but remember, we know that means multiplication. So don't forget that as you're moving through your stuff. What other questions do you guys have here? Right, let's have you guys try one, and then we'll throw it in reverse, go the other way. So you guys try this. Check with your neighbors to see. I see a lot of good work with this one. What did you guys notice first? Yes. So that would become what, y'all know? Yes. And then, so you got your power rule. What did we see next? What did you guys see next when you're here? Yeah, how can I combine these first two terms together? There's a plus sign in between. Multiplication. And if I'm thinking about x to the 5th times 9, I saw almost everybody write this with good math grammar, which was how? Did you write x to the 5th times 9? No. How did you guys write it? I saw everybody doing it. 9x to the 5th. That's, our nice math grammar. So I have log of m. And then if I have a minus log of m, how can I bring that together? Divide. So here's what I want to make sure everybody's clear about. Single log expression. Look down at your paper. Did you write log one time or did you write it 2 times? So if you wrote it 1 time, you're probably on the right track. And you had 9x to the 5th over m. So this is single log expression, meaning my numerator over denominator inside the parentheses here. If you had log of 9x to the 5th over log of m, those are not equivalent expressions. So that would not be how you would want to express your answer. You want to think about when you're bringing things together, it's all inside the parentheses together of what you're taking the log of. Just want to make sure everybody's clear about that. Anybody have any other questions with that? Alrighty. Let's go the other way. So we're going to expand now. So jot this question down, and then we'll see what you're noticing. All right. Our directions, expand the logarithm slowly as possible. So you're doing the opposite reverse process of what you were just doing before. So thinking about that, what are you guys noticing here that maybe you want to do to start off? Log plus log. So why are you saying log plus log?
Because like multiply them to get it together.
You gotta multiply them to get, they are multiplying, right? But what other thing is going on? What do you see, Ruby? The exponent. So with our order of operations, we want to tackle the exponent first. So this 3 is going to go out to the front. And then, does everybody see how this exponent of 3 applies both to 5 and the m? How do we see that? How do you know it's cubing all of it? What do you see? Outside of parentheses, yes. So I'm going to have 5m here. Now let's stick with Morgan's idea. A plus. Why do we want a plus? Because 5m means what operation? Multiplication. So keep that 3 all the way out in front because that means it's being applied to both. So I have log of 5 plus log of m. And if we're this far, one more thing. What do we see? Or one more thing to do, B? One more thing to do would be 2. I like that idea. What do you see, Evan?
Where did 10 come from?
10. That's log.
Oh, that's log. Okay.
But I was wondering if you were asking about the base, which obviously we know here our base is 10. What else do you guys see? Just an algebra move. Distribute the 3. So this would be 3 log of 5 plus 3 log of m. So, like I said, there's going to be multiple routes to doing this. Your other route you could have done, if you kind of wanted to do the addition piece first, how you could have gone about doing that would be to apply the 3 inside your parentheses first at the beginning. So you'd have log base 5 of 3, and then m to the 3rd, and then you break it apart with addition, and then you move your 3 out front. So either way, you should have always simplified to this 3 log of 5 plus 3 log of m in the end. glad you didn't ask, Evan. How do we have 10 grams? Somebody has definitely asked me that before. Okay, so let's look at example 4. Give you guys a second to jot this down. I would say this is probably like a quiz level type problem that you'll see next week. Not next week, but the week after. So we're going to expand the log fully as possible. Yeah. Yes. And we have log base 3 square root of xy cubed over 27. So like I said, take a second, observe, and what's something you guys noticed here? What do you see, Evan?
27 is 3 to the third.
Yeah, let's keep that in mind. So I'm gonna probably have to evaluate eventually. What else do you guys see? Division. So how can I break up that division? Subtraction. So now let's use that idea Evan just talked to us about. Log base 3 of 27. What would that be equivalent to? 3 to what power gives us 27? 3. So I know this is really minus 3. I want to evaluate when I can, which I can there. If that was 25, I wouldn't evaluate it, right? Because 3 to some power can't get me 25 anyway. Now let's look at like what we still have going on with log base 3 the square root of xy cubed. What are we thinking about with that? Anybody seeing anything? What do you think, Laura?
Did you break the y out of like 15 compared to y?
Oh, to simplify it? Yes, but that's not going to kind of help us in the sense of then we'd have 2 different y's, right? What do you think, Sabina?
You could turn it into like an exponent.
You can turn them into exponents. So don't forget those skills we did back in November, December, because these come to play a lot with our logs. So if I'm turning them into exponents, x would be raised to what power? 1/2. Y would be raised to what power? 3 over 2, yes. Now, what do you guys see that we could do next? What do you guys see here?
You could break it up into log base half plus 20y.
Good. We would want to break it up with addition next because we are multiplying. I wouldn't want to bring my coefficients out in front here because then it's like 1/2 times 3 over 2. Like does everybody see how this exponent goes with x? 1/2, 3 over 2 goes with y. I could only bring an exponent out like we did in our problem before if it's applied to everything. So now I have them broken up, and now what's our last step? What would your last step be now that you're here?
With the exponents on the outside.
There you go. So I'd have 1/2 log base 3 of x plus 3 over 2 log base 3 of y minus 3. So what you guys should start to notice, and I would say probably the biggest question with expanding is, have I expanded fully? And how you know is, do you have any exponents? You should say, no, they're all coefficients. Do I have any terms multiplied or divided together? You should know I broke it all up into addition or subtraction. And then 3, did you evaluate when it's possible? And yes, we did here. So something else you could have done instead from your numerator is you could have all thought about all of this as 1/2. So that would have been 1/2 times log base 3 of xy cubed. And then from there, you would have broken it up with addition, move your exponent out for your y, and then distributed. This option that Sabina recommended from going to the powers from the beginning gives us actually one less step. So, just keep that in mind. You could have also thought about it that way too. Morgan?
Why is it -3?
Great question. This log base 3 of 27. Where was your 27 originally? Denominator. So this is a good way to always visually check your work. If you are in the denominator, your sign has to be minus.
But why is it 3?
Who can explain why did this become 3? What do you think, Sabina?
3 to the power of 3 is 27.
Yeah. 3 to the power of 3 is 27. So we evaluated that. Because that's what log base 3 of 27 equals. If you needed a second, write it out on the side. Right? And Morgan, you just swoop it around. 3 to what power gives you 27? And that was equal to 3.
Got it.
Remember warm up?
Yes.
Yes. Okay. So this stuff, if it's a little weird to you right now, it gets a lot easier with practice. Like I said from that first problem, you're just going to be able to kind of look at stuff and do it eventually, with a lot of practice. So let's get there with some practice. And I'm going to give you guys the scenario first of condensing into a single log. Evaluate if possible. We have 6 problems up here on the board, and I want you guys to pick 4. And what we're going to do maybe a minute or 2 after 10:30, we'll check them. And I'll put the solutions on the board so you check the 4 you did. What do you think you could do if you finish your 4 before time's up?
I'll come out.
No, just do more, right?
Oh.